Here's our review for trail marker 4. Look at the 10 questions here. A lot of solving, a lot of working with lines, a little bit of polynomial work, addition, multiplication. But you guys have seen all of these skills before. So let's follow along. Let's pass this trail marker. Last one of the year. Here we go. First thing, I see these parentheses in question 1, so I'm going to use the distributive property. So I get negative 3x minus 6 because it's a negative times a positive. Just going to rewrite the plus 6 equals negative 27. Now let's combine like terms. Because the negative 6 and the positive 6 are on the exact same side of the equal sign, we're just going to combine like terms. Negative 6 plus 6 actually cancels each other out there because negative plus is the same number, equals negative 27. And then we got to solve for x, so I'm going to divide by negative 3. A negative divided by negative is a positive 9. Okay, question 2. Same idea, solving a linear equation, but now we have variables on both sides. So the first thing I'm going to do is I'm going to move the variable to one side. So I'm going to add 5x here, but what I do to one side I have to do to the other. So I get 20x minus 7 equals 13. So I just rewrote exactly what's left, the minus 7 and the equals 13. Now I'm going to move the constants to the other side. So I'm going to add 7 to both sides. Notice how those cancel out. So now I have 20x equals 20. Now we divide by 20, and x equals 1. Okay, question 3. Perform the operation. Before you do anything, look at the operation. It's addition, so all I'm doing is combining like terms. So what I'm going to do is I'm going to underline the like terms. There's my x squareds, so now I have 8 of them, 5 plus 3. Next I'm going to look at my x's. Negative 2x minus 6 more is a negative 8x. Then I'm going to underline the constants. Well, all we have is positive 3, and that's all you got to do. Do not distribute. Look for the operation first. Okay, question number 4. Graph the line. You always start with the y-intercept. It's a y-intercept, so it's got to be on the y-axis, the up or down. So I'm going to go down to negative 5, and I'm going to plot that point. That's where I start my graph, from that y-intercept. The next is 1 over 3, which is the slope. This is my rise, and this is my run. Because it's a positive 1, that means I'm going to go up 1, and because it's a positive 3 in the denominator, I'm going to the right 3. So from the y-intercept, I'm going to go up 1 over 1, 2, 3. And I got this point, up 1 over 1, 2, 3, and I got that point. Okay, so start with the y-intercept always, which is right here, and then apply the slope to that y-intercept. You start from here, not the origin. Start from that y-intercept. Okay, question 5. Rewrite in slope-intercept form. Well, let's remind ourselves, because we actually just did a problem in slope-intercept form. Y equals mx plus b, so that means I need to get the y by itself. First thing I'm going to do is I'm going to move the x to the other side. Okay, so I'm left with 2y on the left. And then if you notice, 8 and a negative 3x are not like terms. And if you look right in my equation, mx plus b, the mx is first. So I'm going to write the negative 3x first, plus 8. You're not wrong if you write 8 minus 3x, but I want to kind of make it look like this mx plus b. Then I'm going to divide by 2. Remember that I have to divide every single term in the equation. I'm left with y equals negative 3 over 2x plus 4. 3 over 2 cannot be simplified, and 8 divided by 2 is 4. Perform the operation. Write your answer in standard form. Well, now if I look, I don't have any operation, so it's got to be multiplication. So let's use our distributive property. Here we go. Negative 3x times 4x gives me negative 12x squared. X times x, you always get the x squared. Big common mistake here. Now I'm going to distribute the negative 3x to a negative 1. Double negative makes it a positive. 3 times 1 is 3, and I still have the x there. Now we start distributing the 7. 7 times 4x is a positive 28x, and 7 times negative 1 is a negative 7. Now all we do is combine like terms. I got my x squared here, no other x squareds, done with that. Got my constant here, no other constants, done with that. But I do have these like terms in the middle here. So I'm going to rewrite the negative 12x squared. 3 plus 28 is a positive 31x minus 7. It's in standard form because I'm starting with the highest exponent first and then going down from there. Okay, rewrite the quadratic expression in vertex form. I need to complete the square for this, so here are our steps. X squared plus 12x plus blank. Then I'm going to write the constant again plus another blank. Now I need to figure out what goes in the blank. If you remember, it's always b over 2 squared. Here's my b. Okay, it's always b over 2 squared, so I'm going to get 12 over 2 squared. I have to simplify what's inside the parentheses, which gives me 6 squared, which is 36. Okay, so that's what goes in the blank, but remember what I do to one part, I have to just simplify to make it 0, so I can't add 36 again, because that's going to be adding 72 to this whole expression. So I need to actually do the opposite in the other blank by subtracting 36. And if you notice here, positive 36 minus 36 gives you 0, and I don't want to change the value. And by adding 0, you're not changing the value. Now I'm going to factor this first polynomial. So what multiplies to 12, or sorry, what multiplies to 36 and adds to 12? Well, it's got to be the same number twice. That's why it's a perfect square completing the square. It's going to be x plus 6, and because there's two of them, I'm going to write it as squared. Now I just combine my terms out here. Negative 5 minus 36 more is a negative 41. There's vertex form. Solve this system. Okay, if I look, my x's are lined up, my y's are lined up, my constants are lined up. So let's use elimination. Add down 5x, or sorry, negative 3x plus 5x gives me a positive 2x. Positive y minus y cancels out, and 8 plus 4 equals 12. Well, now if you notice, the reason why it's called elimination is because we eliminated the y's. We eliminated one of the variables. Now I'm going to solve for x. I get x equals 6. You are not done. Remember, a system of equations has three possible solutions. No solution means the lines do not intersect. All solutions means the line are the exact same line, and one solution, which is a coordinate point. So right now I only have the x value. So pick either line. Let's just pick the top one. And I'm going to plug in the value that I have, and I'm going to solve for the missing y value. So I get negative 18 plus y equals 8. Remember that I plugged this negative 6 in for x. Now I'm going to add 18 to both sides, add 18, and I get y equals 26. So my x value is 6, my y value is 26. I want to make sure I write it as a coordinate, 6 comma 26, and there's my answer. That's where the two lines intersect. Okay, take a look. Two more questions. Factor the expression below. Well, if you look, we actually already factored once. Remember, we figured out in question 7 what multiplies to the constant and adds to b. So what multiplies to c and adds to b, same property. What multiplies to c and adds to b. So I need to figure out multiply to negative 18 and add to negative 3. Okay, so what multiplies to negative 18? Well, there are couple possible factors: 18 and 1, 9 and 2, 6 and 3. So let's figure out which one it is. It's got to add to negative 3. Well, 9 and 2 would add to maybe a 7 or an 11. 16 or 18 and 1 would be 19 and 17. So it's 6 and 3. There we go. Okay, so the two numbers have to be a negative 6 and a positive 3, because negative 6 times 3 is negative 18, and negative 6 plus 3 is negative 3. So the way I write my factors with these two numbers is x minus 6, x plus 3. Now, if there was an equal 0, then we could solve, but there's not, so all we're doing is factoring. We're done right here. The last one. Write the equation of the line that passes through this point and has the slope of here. Remember, slope stands for m, so I already have my m, and my equation is y equals mx plus b. We're actually lucky. The y-intercept stands for the b here. This is a y-intercept. And remember, a y-intercept has an x value of 0. So actually, this 0, 3 is the b. So I already have the m and the b. My equation is negative 1 over 2x plus 3. There we go. If I did not give you this point that was a y-intercept, you simply take the x value from that point and plug it in for x, take the y value and plug it in for y, and then solve for b, given the slope negative 1/2. But in this case, we were given it. So take a look. Okay, I know it seems like a lot, but just solving some equations, a system, graphing lines,